In this video, we're going to talk about Introduction to Differential Equations. Differential equation is an equation that contains an unknown function together with one or more of its derivatives. So look at the first example. A, B, C, and D. They are examples of differential equations. If the unknown function depends on a single independent variable, then the equation is called an ordinary differential equation. We call it ODE. The derivative of the unknown function is an ordinary derivative. On the other hand, if the unknown function depends on more than one independent variable, then the equation is a partial differential equation. So we call this a PDE. ODE is going to be similar than PDE. In other words, PDE is going to be more complicated to solve. Alright, so we look at this one right here. A, B, and D. This is called ODE. Only C right here. This is PDE. Because this guy has two variables, S and Y. This guy, A, B, D, only have one variable, which is S, and S. Now, the order of a differential equation is the order of the highest derivative of the unknown function appearing in the equation. Now, look at this example right here. A right here. This is the first derivative. So, it's going to be the first order. This guy, the second derivative. The second derivative. So, it's going to be the second order. D right here. This is the third derivative. So this going to be third order. And the last one, solution. A solution of a differential equation is a function defined on some interval I with ordinary differential equation, or on some domain D in two or higher dimensions with partial differential equation, with the property that the equation reduces to an identity when the function is substituted into the equation. Alright, so we take a look at example number 2. Given the second order ordinary differential equation, so this is ODE. Alright, second order, which means we have the second derivative. Now, we need to show that the function y equal s squared plus 2s cubed is a solution. Okay, so we have this is the second derivative. This is the first derivative. Alright, so we just take the first derivative of this one. So y prime equal s squared, it turned out to be 2s. This is 2s cubed, it turned out to be 6s squared. Now we take the second derivative of this one. It's going to be 2 plus 12s. Now we substitute these two functions into this equation. So it turned out to be s squared times y double ram. Double ram is going to be right here. It's going to be 2 plus 12s minus 2s y prime is going to be 2s plus 6s squared. Alright, plus 2y plus 2 times s squared plus 2s cubed. Now we need to check it to see if it's equal for s cubed. Okay, if it's equal, and then this solution. If it's not equal, this is not solution. So we just distribute this one. It's turned out to be 2s squared plus 12s cubed minus 4s squared, this guy right here, minus 12s cubed when you distribute this one, and then plus 2s squared plus 4s cubed. Alright, now we need to simplify. 2s squared and 2s squared right here, it's going to be 4s squared. 4s squared minus 4s squared is going to be 0. Now 12s cubed minus 12s cubed is going to be 0. You only have this one left, which is 4s cubed. So we just verify that A is the solution. Now we need to check B. G of s equal to s squared plus 3s, and we need to prove this is not a solution, and we do the same process. G prime equal 4s plus 3. G double prime is going to be 4. Alright, now we substitute s squared times y double prime, which means 0 double prime, which means times 4. So I just put 4s squared right here. Minus 2s times y prime, which means z prime. It's going to be 4s plus 3. Alright, plus 2y, which means 2z. So it could be 2s squared plus 3s. Alright, now we need to check this guy if it's equal 4s cubed. Alright, so we have 4s squared right here minus 2s times 4s could be negative 8s squared. Negative 2s times 3 is going to be negative 6s. 2 times 2s squared plus 4s squared. 2 times 3s could be plus 6s. Now we need to simplify. Negative 6s gone. 4s squared plus 4s squared is going to be 8s squared. 8s squared minus 8s squared is going to be 0. So the left hand side equals 0. The right hand side 4s cubed. So this is not a solution because they're not equal. Alright. Now let's move on to the third example. Show that u equal cosine of s hyperbolic sine y plus sine s hyperbolic cosine y is a solution of Laplace equation. Right, the second derivative of u with respect to s plus second derivative of u with respect to y equals 0. Alright, so recall derivative of cosine of s is going to be sine, negative sine of s. Derivative of sine of s is going to be cosine of s. Derivative of hyperbolic sine is going to be hyperbolic cosine. Derivative of hyperbolic cosine is going to be sine. First, we need to take the derivative of the function u with respect to s. So we have du over ds. Now, du over ds, which means we treat s as variable and y is going to be constant. Alright, so it turned out to be derivative of cosine s. It should be negative sine s. And then you need to rewrite hyperbolic sine y. Derivative of sine, it should be cosine of s. So cosine of s and hyperbolic cosine s. Cosine y, sorry. Now, take the second derivative of the function u with respect to s. It's going to be derivative of sine. It should be cosine, so it can be negative cosine s. And this one you just rewrite sine y. Derivative of cosine is going to be negative sine, so it's negative sine s. And rewrite this one cosine y. Now check the first derivative of u with respect to y. It turns out to be cosine s hyperbolic cosine y plus sine s hyperbolic sine y. Now take the second derivative of u with respect to y. It's gonna be cosine s sine y plus sine s cosine y. Alright, so we need to add this guy up. So we need to add this guy up to see if it's equal to 0. The second derivative of u with respect to s plus second derivative of u with respect to y equal this guy and this guy. You see that opposite, you add them up, it's gonna be 0. This guy and this guy opposite, add them up, it's gonna be 0. So the answer is 0. So it's yes. Now let's move on to the example number 4. Find real number r such that y equal e to the rs is a solution of the differential equation y double prime minus 2y prime minus 8y equals 0. Alright, so we need to take the first derivative of this one. So y prime equal e to the r times s is going to be equal r e to the r times s. Now y double prime is going to be, take the derivative of this one, it's going to be r squared e to the r times s. Now we substitute into this equation, so we have what? Y double prime is to be r squared e to the r s minus 2 times r e to the r s right here, because this is y prime, and then minus 8 times y, but y equal e to the rs. Alright, we need to prove this one equal 0. So let's see what. This is r square e to the r s. Now you need to multiply this one, it's going to be minus 2 r e to the r s minus a e to the r s. Alright, now we factor e to the r s out. So it turned out to be r squared minus 2r minus 8. Alright, equal 0. We know that this guy always different from 0 for all values of s. Alright, so if this guy multiply this guy equal 0, only this guy equal 0. Now we need to factor this one. If we factor this one, we use s method right here. Put negative 8 right here and negative 2 right here. Find two numbers multiply equal negative 8, add up to negative 2. It should be negative 4 and 2. So we have r minus 4 times r minus 2 plus 2 equal 0. So two values is going to be r equal 4 and r equal negative 2. So when r equal 4, we substitute back to this equation right here. We have the first solution, y equal e to the 4s, and then r equal negative 2, substitute over here. So y equal e to the negative 2s. Now example number 5, it's going to be similar to example number 4. Alright, find real number r such that y equal s to the r is a solution of the differential equation y double prime minus 4 over s y prime plus 6 over s squared times y equal 0. Y equal s to the r. So we need to take the first derivative of this one. So y prime should be equal r s to the r minus 1. Second derivative, it should be r times r minus 1 times s to the r minus 2. Alright, and we substitute this guy into this equation right here. And we solve it. So y double prime should be r times r minus 1 times s to the r minus 2 minus 4 over s y prime should be times r s to the r minus 1 and then plus 6 over s squared times y equal s to the r is going to be equal 0. Next one, we just rewrite this r times r minus 1 s to the r minus 2 minus, now s right here is going to be s power 1. We bring it to the top, it turns out to be s power negative 1. So negative 1, and then you need to add this one, so it turns out to be negative 4r s to the r minus 2. Plus, this is the same thing, s to the power 2 right here, bring it to the top, it turns out to be s to the negative 2, and you combine this one, it turns out to be 6 s to the r minus 2 equal 0. Alright, now we just factor s to the r minus 2 out, so s right here to the r minus 2 is going to be r, for this one, so it can be r squared minus r, and this is minus 4r, and this is plus 6 equal 0. Plus 6 equal 0. You know that this guy all y different from 0, so we only need this one equal 0. So it turns out to be r squared negative r minus 4r, it should be negative 5r plus 6 equal 0. Now you need to factor this one, so you need to find two integers multiply equal 6 add up to negative 5. It should be negative 2 and negative 3. So it turns out to be r minus 2 times r minus 3 equal 0. So you have two solutions, r equal 2 and r equal 3. You substitute back into this equation right here. So y equal s squared. And then y equal s cubed. And these are two solutions. Now let's move on to the last example, example 6. Find real numbers a, if possible, such that z equal a times e to the 2s is the solution of the differential equation y double prime minus 3y prime minus 10y equal 4 times e to the 2s. Alright, so basically we have this one, we just take the first derivative. So z equal a times e to the 2s. Now we have z prime, it should be equal to a times e to the 2s. Z double prime equal 4a times e to the 2s. Now you substitute into this equation, so we have 4a times e to the 2s minus 3 times y prime, it's going to be 2a times e to the 2s minus 10 times y, but y right here, a times e to the 2s equal 4 times e to the 2s. Now we need to simplify. Alright, 4a, and this is negative 6a, and this could be negative 10a right here. So it turns out to be 4a, negative 6a, and negative 10a. So it turns out to be 4 minus 6, it could be negative 2, negative 2 minus 10, it should be negative 12a e to the 2s equal 4 e to the 2s. Alright, now we just equate the coefficient both sides. So we have negative 12a equal 4. A equal negative 1/3. So if a equal negative 1/3, substitute back over here. So g equal negative 1/3 e to the 2s. This is the solution. And it's a good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand in mine.